Good evening, sir. I'm Sneha Udikari from 3rd year AC department. My university roll number is 34900323049. So today I will discuss about operation of Mosfet. So this is our first slide. It's about introduction to Mosfet. So Mosfet is a metal oxide semiconductor field effect transistor, which is a voltage controlled semiconductor device used for amplification and switching. It controls the current between drain and source terminals by applying voltage to the gate terminal. The gate is electrically insulated from the channel by a thin silicon dioxide SiO2 layer, so almost no gate current flows, and MOSFET works on the principle of the electric field effect, where the gate voltage creates or removes a conductive channel. It offers very high input impedance, low power consumption, and fast switching speed compared to BJT. MOSFETs are available in two types, N-channel and P-channel. It is the basic building block of CMOS VLSI microprocessors, power supplies, and digital ICs. Due to small size and easy integration, MOSFET dominates modern electronic and power electronic systems. So here we can see the symbol of MOSFET and the picture of the MOSFET, which indicating the gate, drain, and source. Our next slide is about basic structure of MOSFET. A MOSFET consists of four terminals: gate, drain, source, substrate or body. The gate terminal is separated from the semiconductor material by a thin insulating layer of silicon dioxide, SiO2. The region between drain and source is called the channel, whose conductivity is controlled by gate voltage. The drain and source are heavily doped semiconductor regions, while the substrate is lightly doped. There is no direct electrical connection between gate and channel, making the input impedance extremely high. MOSFETs are fabricated into two main forms. First is N-channel MOSFET, where electrons are majority carriers, and second is P-channel MOSFET, where holes are majority carriers. It's depending on construction. MOSFETs are classified as enhancement type and depletion type. So here this side working principle of MOSFET. MOSFET operates on the principle of the electric field effect, where the gate voltage controls the flow of current between drain and source. The gate terminal is insulated from the channel by a SiO2 layer. So practically no gate current flows. And when no gate voltage, it means VGS equal to 0 is applied, the channel is absent in enhancement type and the device remains off. When gate voltage exceeds the threshold voltage, it means VGS greater than VTH, and electric field is created in the substrate. This electric field attracts charge carriers and forms a conductive inversion layer between source and drain. Once the channel is formed, applying drain to source voltage VDS allows current ID to flow through the device. The amount of drain current is controlled only by gate voltage, making MOSFET a voltage controlled device. By varying VGS and VDS. MOSFET operates in cutoff, linear, and saturation regions. Formation of channel. When VGS equal to 0, no channel exists. It means device is off. And when VGS greater than threshold voltage, then electrons accumulate near the oxide layer for NMOS, and an inversion layer or channel forms between source and drain. The drain current starts flowing. It means device turns on. Modes of operation. MOSFET operates in three regions: cutoff region, linear region, and third is saturation region. So for cutoff region, VGS is less than VTH. No channel formed and ID is proportional to 0. It means MOSFET is off. And for linear region, VGS is greater than VTH and VDS small. And MOSFET behaves like a variable resistor. ID increases linearly with VDS. And for saturation region, VGS is greater than VTH and VDS is high. Current becomes almost constant and used for amplification. So here we will discuss about the drain current equation. In linear region, ID equal to mu COX W by L VGS minus VTH into VDS minus VDS squared by 2, and in saturation region ID equal to half of mu COX W by L VGS minus VTH whole square, where mu equal to mobility of charge carriers and COX equal to oxide capacitance and W by L equal to width to length ratio. And here we can see a drain characteristic of MOSFET. This graph is indicating the drain characteristics of MOSFET. So here the characteristics of MOSFET. So first is voltage controlled device. Drain current is controlled by gate voltage, not by input current. And the another is very high input impedance. Due to SiO2 insulation, gate current is almost zero in the order of nanoamperes. And third is low power consumption. No gate current leads to minimal power loss. And it's most important, the high efficiency produces less heat compared to BJT. And another is unipolar device. Current conduction is due to only one type of charge carrier, electrons in NMOS and holes in PMOS. High drain resistance provides good amplification capability. And the last one is noise performance, lower noise compared to bipolar transistors. So here we will discuss about the applications of MOSFET. Switching applications. Widely used as electronic switches in digital circuits due to fast on or off speed and low power loss. Second is amplifiers used in audio, RF, and operational amplifiers because of high input impedance and good gain. Third is power electronics used in SMPS, inverters, UPS, and motor drives for efficient power control. Digital integrated circuits forms the basic building block of CMOS logic gates, microprocessors, and memory devices. Voltage regulators used in DC-DC converters and voltage regulation circuits. Then the next is automotive electronics used in electric vehicles, battery management, and lighting control. And the last is communication systems applied in RF amplifiers, mixers, and signal processing circuits. So the next slide is about advantages of MOSFET. Okay, so the advantages are first is very high input impedance. Gate is insulated by SiO2, so gate current is almost zero and loading effect is negligible. And second is low power consumption. Voltage controlled operation reduces power loss and ideal for portable devices. And the third is fast switching speed. It's suitable for high frequency and digital applications like CMOS circuits. And the next is better thermal stability. Performance is less affected by temperature compared to BJT. High efficiency and low on resistance. Produces less heat and improves power conversion efficiency. And the last is easy integration and small size. For that, widely used in VLSI and IC fabrication. So here is our conclusion. MOSFET is a voltage controlled semiconductor device widely used for switching and amplification. It operates by controlling the channel conductivity through gate voltage based on the field effect principle. The device provides high input impedance, low power consumption, and fast switching speed because of its small size and easy fabrication. MOSFET is the main element of CMOS and VLSI technology. Thus, MOSFET plays a vital role in modern digital, analog, and power electronic systems. Thank you.